Welcome to Leko Academy. In this video, we are going to handle a question that came in 2023, Science Paper 1 GCE. So Science Paper 1, that is Physics. So this is Section C. So C1 here they're saying, so figure C 1.1 shows a velocity time graph of a car of mass 1200 kg. So this is the diagram here, the velocity time graph. So this is the velocity time graph, and this side here we have the velocity, down here we have the time. Now the first question, which is question A, they are saying calculate the acceleration of the car in the first 2 seconds. So in the first 2 seconds, from this point to that point, so this part here, it is the acceleration part, because acceleration is the change of velocity with time. So to calculate for acceleration, we collect data. So if we collect data, so this is C1A. So if we collect data, the formula that we are going to apply, the formula for acceleration is equal to V minus U over time. So this V represents the final velocity, and our final velocity from this point to that point, this is a 30. So our final velocity, that is 30 meter per second. Our initial velocity, where the car started accelerating, it is here, which is a 0. So this is a 0 meter per second. The time they are saying in 2 seconds, in the first 2 seconds. So from this point to that point, that is 2 seconds. Now that we have the data, we can substitute in the formula. So acceleration therefore is equal to our final velocity, that is 30, minus initial velocity, which is a 0, over the time, that is 2. 30 minus 0, it will give us 30 over 2. This 2 into 30, that is a 15. Therefore, acceleration is equal to 15. And the SI unit for acceleration, that is meter per second squared. So this is our acceleration. The other question, so question B, they're saying, explain why the acceleration is 0 meter per second squared between 2 seconds and 4 seconds. So if we check on our diagram here, between 2 and 4, this part here, why is acceleration equal to 0 at this part? So as I said earlier, acceleration is the rate of change of velocity with time. So here, if we check at this point between 2 and 4, here the velocity was constant. No wonder acceleration is equal to 0. So for question B, they are saying why is acceleration equal to 0. So it is equal to 0 because velocity is constant. So that's the reason why it is equal to 0. There is no change in velocity. So we are saying there is no change in velocity. So this is the reason why acceleration is equal to 0. We can go to the next question. So the other question here, question C, they are saying calculate the displacement of the car while its velocity was increasing. So displacement is the distance. So they're saying we calculate the distance when the velocity of the car was increasing. So where the velocity it is increasing, it is from this point to that point. So this is the part that we are dealing with. Now when calculating the distance or the displacement, the formula is determined by the shape. So this shape here, this is a triangle. And the formula for finding the distance of a triangle, so number C, the formula that is distance is equal to 1 over 2 multiplied by BH, where this B is the base, HE is the height. So distance is equal to 1 over 2 multiplied by, now if we check the base it is the distance from this point to that point. So the distance from this point to that point, that is 2. And our height, it is the distance from this point to that point, so which is 30. So this is 2 multiplied by 30. So 1 multiplied by 2, it will give us 2. 2 multiplied by 30, that is 60. 60 divided by this 2, it will give us 30. So distance therefore is equal to 30. Remember to put the units. So the unit for the distance, it is the meter. The next question. So the next question they are saying, calculate the resultant force on this car during its acceleration. So to calculate the resultant force, we know that the resultant force, it is given by, so this is question D. Question D, the resultant force is given by F is equal to mass multiplied by acceleration. So if we collect data, in the first statement, they said the mass, that is the mass of a car, that is 1200 kg. So the mass, which is m, is equal to 1200 kg. Acceleration, this one we have, so acceleration, it is this 15. So acceleration, that is 15 meter per second squared. Now that we have this, we can calculate the force. So force is equal to our mass, that is 1200 multiplied by 15. So 1200 multiplied by 15, this one, it will give us 18,000. The unit for the force, that is Newton. Number E, they are saying distinguish between speed and velocity. So speed and velocity, so if we check the marks here, that is 1 mark. So the difference for this one, so distinguish, when they say distinguish, is the same as giving the difference. So this is number E. So speed, the difference between speed and velocity. Speed is a scalar quantity. So when we say scalar quantity, it means that it has only the magnitude. Whereas velocity, so for velocity, velocity is a vector quantity. So vector quantity meaning it has both magnitude and direction. So this is the difference between the speed and the velocity. The speed is a scalar quantity, velocity is a vector quantity. Now the last question here for number C1, they are saying calculate the displacement of the car for the whole journey. So the displacement of the car for the whole journey, which is the distance for the whole journey. So to calculate the distance, as I said, the distance, the formula for the distance is determined by the shape given. So if we check the shapes that we have, we can divide this into 3 parts. This is the triangle, this is a rectangle, and also this is a triangle. Or if we don't divide this part, if we check this shape, this is a trapezium. So for this one, you can use 2 ways to find the distance. So I'll start with for the trapezium. So distance is equal to half for the trapezium, which is half a plus b height. Distance is equal to half. Now our a, it is the length of the rectangle from this point to that point. That is our a. So the length of this rectangle from this point to that point, we find the difference. So this is 2, this is 4. 4 minus 2, it will give us 2. Plus b is the specific time. So if we check the time from this point to that point for the whole shape, that is 8. H is the height, the distance from this point to that point, which is a 30. So our h, that is 30. So distance therefore is equal to 1 over 2. 2 plus 8, that is a 10. So this is 10. And there we have a 30. So 10 multiplied by 30, it will give us 300. Divided by 2. 2 into 300, this is a 150 meters. So this is how you calculate the distance if you are using for the trapezium. If you are not comfortable with this, you can calculate part by part. As I said, here we have 3 shapes. The first shape, so this one I'll name it as part A, this one part B, and this one part C. So to start with, for number A, the distance of A we already calculated for this one, where I said half BH, since it is a triangle. Our B, the base from this point to that point, which is a 2, multiplied by the height, the distance from this point to that point, which is 30. So this one, it gave us 30 meters. So this is not our final answer, we're still calculating for the other part. So this is part A, part B. So for part B, this shape here is a rectangle. So the distance is equal to LB when calculating the distance on a rectangle. L represents the length from this point to that point, which is the difference. So the difference here, that is 2. 4 minus 2, it will give us 2. Multiplied by B, which is the breadth, the distance from this point to that point, that is 30. So 2 multiplied by 30, this is 60 meters. So for part B we are done. Now for part C is also a rectangle. If we check this shape, this is a rectangle. So the formula, distance is equal to half BH. Our B is the base. So if we check here, the base, the distance from this point to that point. So here we have a 4 and there we have a 8. So the difference here, 8 minus 4, that is 4. Our height, it is the distance from this point to that point, which is 30. So our B, that is 4, multiplied by 30. So we can simplify this. 2 into 4, that is 2. 2 multiplied by 30 to give us 60 meters. Now after calculating part by part, you then add the distances. So the distance therefore is equal to the total distance for the journey, A plus B plus C. The distance for A, for part A, that is 30, for B that is 60, and for C that is 60. So this is 30 plus 60 plus 60. So when we add these figures, 30 plus 60, this is 90. 90 plus 60, it will give us 150 meters. So it depends with the formula that you're comfortable with, or the procedure. If you want, you use this one for the trapezium, or you calculate part by part. So this is how we handle questions under time graph.